What's up, everybody? Welcome back to Make It and Break It. My name's Andrew, and today we're giving you guys another way to use your 3D printer to help you with your fabrication tooling. So previously, some of our previous stuff has been looking at tube bending type stuff, how to mark them, that sort of thing, some nice templating tools. This is for 1-inch tube, this is for 2-inch tube, with the proper centerline radiuses for each bend, as well as some marking tools here. But eventually, you're going to have to weld stuff together. As you can see kind of off here to my left, I've got, I don't know if you can see this setup, but at least these here, I've got some square tube, some angle iron, and some round tube here that's going to start going into a bunch of different projects for us. Not all of them are going to be using those types of tools. In fact, the angle iron over here is going to, in all likelihood, go into something that's more square, like a square chassis frame for maybe a enclosure for our 3D printer. Which brings us to one of the difficulties in building things that are square, and that is, how do you make sure the corners are really good? So normally, if I were building something square with, say, these two pieces of square tube, got caught on the light. These two pieces of square tube, I'd be using a couple different tools. A tool kind of like this. So this is a magnetic square welding tool. Essentially, it's there to help you weld. So it's set up so that this side and this side are 90 degrees apart. This side's a 45, this side's a 45, and you can even do 135 if you really wanted to, somehow. Anyway, but you essentially take this, if I were trying to fit this something up square against this, get that all nice and square in there, and try and make sure you take like this, and then where's our level? A level here, and check, make sure that it's, level there. Check, make sure it's level there, and it's 90 degrees here. And then all this stuff lines up. And it can be a little fiddly to go do that sort of stuff. So I was like, there's gotta be an easier way to do this. And we have a bunch of 3D printers around. I'm sure we can come up with something that makes doing like a T-square or an end on a square frame a lot nicer. And I came up with something, and it's sitting behind me. Ta-da! It's a, I'll call it a fixture. It's a 90-degree jig. So I came up with this. This is actually a pretty quick thing, but I wanted to show you guys because it's got a lot of uses, and it's really simple, and you don't need a huge 3D printer or anything special to make it. Although, if you wanted to get really fancy with it, you could. This is a essentially, the design here is you have these two faces here are 90 degrees apart. So, designed it to be perfectly perpendicular. The print came out very flat, so I'm not too worried about it warping and not being so. And then I put a gap in here. So this little gap, this little square area, is actually there to both let us weld things in a certain way, if you want to, or it allows you to make a T-joint instead of just a corner joint. Let's go down on the floor, and I'll show you how this is supposed to set up. Okay, so ignore the slippers. It's cold, and these are comfortable. So normally, if we were trying to make a 90-degree angle here with these two pieces, let's call it something like that, some sort of 90-degree T angle. We would set it up like that, maybe throw our square in like that, and then maybe throw another one in on this other side down here. And then we'd tack it together, maybe weld it up partially with these squares in, and off you go. That's a pretty good way to do it, but it has a couple problems with it. First, this is not a good way to keep things from rotating. Notice a little nudge like that will move stuff around just with my foot if I'm wandering around. So, and there's not a real good way to clamp these things together and hold them together so that you don't nudge them. And second, if you want to get this really 90 degree precise in this corner down here, you got to spend a lot of time like getting down there and tapping a little bit, and you go put your angle finder on this thing and then maybe tap it a little bit more and get it all good to go. With this new tool, that changes. So instead of using that, you get to use this thing. That can go straight through, and this thing goes in here. And then all you need to do is clamp it in place. So you get any whatever welding clamp you got. Let's go like this, because that's probably how I would use it. And you clamp it in here. And you clamp this one in, get it up here nice and snug, and you have positive control. These things are not going to shift around now because they're being held in place by their own weight, as well as the guiding of the little fences. Now you know that this is 90 degrees from the other one, and it's positively held in place by your fixture. It's a pretty simple design, and the reason I left the cutout is for two reasons. One, it lets you do a T-joint like this, right? So you can have a T-joint set up, but it also gives you access to the back side of the joint if you want to, at least for a joint that fits inside of that square. So in this case, we could access the back side of this joint if we had it, say, mounted up on the table. So that means you can go around and do all of your tacks, assuring that you are in fact level. And in fact, these are really cheap and easy to make. This is an 8x8 square with a 3-inch cutout in the corner, and this is just a radius to get rid of material to get the print times down. But you could print 4 of these and do an entire square and never have to move anything. You wouldn't have to reset, wouldn't have to tack one side and go run to the other side and make sure that side's level. You can literally just clamp them all in place, tack everything together, and you know your square, and then you can just go weld it up, remove it from the fixture. Now, this fixture isn't specifically designed to be welded on or have all the welding completed on while it's in the fixture. That's mostly because of the material. I printed this out of PLA. It looks weird because it's a translucent PLA. It's what I had around and in the machine when I wanted to go print this. But if you wanted to make this weldable or able to survive a little bit of welding, you could print this in a polycarbonate, which is still rigid like PLA, but has a much higher temperature resistance and would probably stand up to a little bit of welding. But you can do something as cheap as this. This is, you know, $4 worth of plastic. They do make some versions of these in like metal. I think you can find it. If I can find one, I'll throw it up here. And those are much more expensive than $4 worth of plastic. So that's it. It's just a tool I came up with to help myself out in some of the upcoming builds. I wanted to share it with you guys because honestly, if I could use it, I bet you a bunch of other people could use it. Makes setup a real cinch for 90-degree corners or 90-degree T-joints. If you want to get fancy with it, you can print them at multiple angles, or you can put a hinge in here and you can make sure that they hinge appropriately. But if you want to keep it simple, it's about 10 minutes in any CAD program. This is very basic shapes. Send it to your cheap 3D printer. I printed this on my CR10 perfectly. And in a few hours, you'll have a great tool to help you out when you're doing your fabrication. So thanks for watching, guys. Again, my name's Andrew. This has been another Make and Break YouTube video. If you like this video, hit like, go down below, comment. If you go ahead and use this or use something similar to this or even the metal ones, definitely let me know in the comment section down below. If you like what we're doing on this channel, we do 3D printing, fabrication tools, as well as motorsports builds, cars, motorcycles, and stuff in that genre. Definitely hit subscribe and ding that bell icon so you get notified when we put out a new video. So thanks for watching, guys, and I'll catch you later.